Welcome to my YouTube channel. In this video, we are going to see the stress analysis of a shaft of 200 diameter and 1 meter length. For that, we need to click on the static structural double click or simply selecting the project schematic area by clicking it and dragging to the project schematic area. The static structural will open. I am going to select two materials. One is static structural and another one is lighter material. If you select lighter material, we are going to see what is going to happen when compared to the stronger material. Okay, let's see. I will just select some lighter material in general material option. I'm just selecting the polyethylene. Okay, polyethylene and the structural steel. um, any other thing you can add? A simple these two enough. Okay. I'll just close it. You can see this polyethylene is showing in the material property data, and I'm going to draw a shaft using design modeler. I just clicked on the design modeler option. Design modeler will open, and I'll draw a diagram. For that drawing a diagram, you need to select sketching and you need to draw a circle. Okay, I'm going to draw a circle exactly at the center point. I'll just escape and I'll zoom first of all so that the circle will be drawn in a correct way. I'm selecting the center point. I'm giving the circle radius. I'm going to dimension it. You can see using the dimension, you can see the dimension d1 represents equal to zero point 0. Okay, I need only uh, 0.02, that is 200 Okay, I'm going to extrude this using this extrude option. I'm going to extrude 1 meter. I need 1 meter extrusion. um, I'm just selecting it and generating it. Okay, so that you can have 1 meter length of 200 diameter shaft. Okay, and closing it, the geometry will be updating in the ANSYS workbench. You can see the tick mark. I'm going to open the ANSYS workbench mechanical. Selecting it, I'm going to give the boundary conditions and I'm going to do the stress analysis of two different materials. One is polyethylene and one is structural steel. Okay, let's wait. The ANSYS workbench will open. Let's wait till that. Yes, you can see ANSYS workbench has been opened. The geometry will be attaching to the ANSYS workbench mechanical. You can see the geometry is being attached. The geometry is being updated in the geometry. Okay, I'll do. I'm going to give the boundary conditions for this. I'm just simply just generating the mesh. Let's see what's the material has been selected for this particular material, for this particular geometry. Um, for solid geometry, structural steel is being assigned. Okay, I'll change to polyethylene in the next analysis. I'm just giving the mesh for this lengthy 1 meter lengthy shaft. I'm going to give the boundary condition simply for force and fixed point. I'm going to give force and fixed support. I'm going to select force one geometry, that is this is geometry. I'm going to, okay, this is a whole shape has been allotted. I'm going to deselect it. Okay, it is not needed. I'm going to select the force for this particular area and I'm going to fix this particular location I'm going to fix it. I'm just selecting it and applying it. You can see this being fixed. I'm selecting this and I'm just giving apply. Force has been fixed. I am going to give components. It is in the x-axis. Okay, so I'm just giving 1000 Newton of load in the x direction. I'm going to do the deformation alone, not needed for stress strain and all those things. I'm just solving this. uh, you can see, excuse me, the stress analysis is being carried out for the 1 meter length shaft. The deformation, you can see the deformation is around, um, you can see around 1 mm. Okay, I'll just use different material. I'm going to delete this structural steel. Okay, I'm going to change the material to polyethylene. Okay, for the same material I'm going to do it. I'm going to just update the mesh and I'm going to do the stress analysis for the same, and I am just updated the material to polyethylene. Let's see the deformation for polyethylene of 1000 Newton load. The deformation will be higher. You can see the deformation is around 2 mm. Okay, the deformation is around 2 mm over here. The deformation for polyethylene is higher when compared to structural steel. Okay, if you liked my video, kindly click on subscribe button, share to your friends. If you have any clarification, comment on the video below. Okay, thanks for watching my video. Thank you.